So failure types can be further broken down into 4 categories. So general circuit failure. So circuit or component has a fixed value. No output or an output that is out of specification. So let me read that again. So general circuit failure. So circuit or component has a fixed value. No output or an output that is out of specification. And we have low input failure. Voltage current or frequency is below normal operating parameters. Yes, so the general failures, I would just say, the component can have like some fixed value where it should actually be outputting, and we're actually not getting seeing those values, right? So we can say it actually out of specification or can be out of calibration, right? We can have our low input failures. So it can be like a low voltage situation, low current, low frequency, or below normal operating parameters. But with this failure right here, the low input failure, I think once you have a failure like this, there is one particular thing that you can actually check first before you actually making a judgment. And so I don't know if nobody can actually tell me what that component would be.
Check your battery first.
Yeah, basically. Once you have a faulty battery, it will affect the voltage, it will affect the current, it will affect the frequency of that sensor. And once you have that for parameters, the operating parameters, the matter off. All right. So once you check your battery and that good, you make sure that the alternator is charging properly when you have no corrosion in the wires or anything like that. Or the sensor connector itself. Right? Or probably the trigger wheel, so whatever the sensor is getting its reading from, probably that can actually alter range, meaning the air gap between the sensor and the component that it is reading is too wide. So that, so that again?
It also can be the alternator belt.
Yeah. So can be the belt skidding. Alright. In other words, it loose. Yeah, man. So what other stuff we could have check? What could actually be causing these issues? So high input failures, so signal has more voltage, more current, or a higher frequency than normal. All right. So this could be like a sensor that is actually breaking down. All right. So improper range. So improper range / performance failure. So sensor or actuator is producing values slightly lower or higher than normal. So device is still functioning, but not as well as it should. Right? So it either underperform or it do too much work. So OBD2 system have this capability. Doing probably too little or too much. So data stream values produced by the vehicle computer provide electrical operating values of sensors, actuators, and circuits. So once we go, on the scan tool, we can actually data stream with the scan tool. So this is one that we should actually data stream our live data, in other words, and actually see the data of sensors, actuators, and other stuff, pulse width point injectors, and all these things. And if it's a GDI system, we can actually say the fuel pressure at idle and the fuel pressure at different RPM rate range. I will know so the GDI system we can't actually use a fuel pressure tester to actually test the fuel pressure on these systems. Because with these systems at idle, sometimes we'll be seeing like minimum of like 500 psi at idle. And at a certain RPM range, you can actually see upwards up to like 36,000 psi. So they would actually change it from 1,000 and then it starts at Pascal, some megapascal on these readings. And that are the pressures. So just imagine your power washer you used to wash a car. Most of those go up to like 17,000 psi, and you have injector now in your vehicle spraying at 36,000 psi. So this is why we don't normally use like fuel pressure regularly testers to test these things. But once we know the values of at a certain RPM, we can actually tell if it is bad. So those can actually be like a pain to deal with if you don't know the values. Wait for have at a certain RPM range. Or we can just refer to the service manual to help us or guide us with that information. So values can be read on the scan tool, digital display, and compare to known values in the service manual. So this is basically what I was saying. So once you have the known values, you can actually use it to compare to know if these sensors are within parameters. Yan, yan engine off, KOEO, right? Diagnostics. So we have two categories of that. So we have a key on engine off or a key on engine on. So meaning you can do a diagnostic scan with the key on, which is just the ignition being on and the engine is off, or you can do that while the engine is running. So on most vehicles, diagnostic trouble codes, data stream values, and some functional tests are available with the key on and the engine off. KOEO. That's what you'll probably see on the scan tool instead of the full writing out. Now we have our engine off diagnostics are usually performed before any engine running diagnostic. And sometimes the reason why them do that is you actually want to like, so for instance, you want to scan the car, but you know eat up the engine or add heat to the engine based on whatever test you are doing. So that gives you the luxury of actually scanning the car without the engine running. Or sometimes you just want to select the values of certain sensors before you actually start to add heat to it to see what change or what drastic change make after you start the car. so you can make a comparison off and while running. So key on engine off diagnostics. So review codes, key on engine off code, fix first. So ear charge, so we have what is 54. So we have, I think it's a code 54 right here. So ear charge temp signal high, and that's what crank off, continuous memory code fix last. This scan tool shows a problem with the ear charge temperature sensor circuit, right? So checking the sensor connector after the trouble code is reviewed. So, we can check the sensor connector just to make sure we don't have no corrosion or moisture in the connector itself. That are going to interfere with the signal that the sensor is actually sending to the computer itself. Now we have our wiggle test. So wiggle test, actually we use that to make sure, to check if we have no break in the wire. Alright. So some vehicles support a wiggle test. Others allow the access. So others allow you to access data stream information while you perform the test. To perform a wiggle test, sorry. To perform a wiggle test, connect a scan tool, choose wiggle test mode or data stream, flex suspected RNS connector while watching for DTC data value change or scan tool indicators. Yes, so like for instance, so normal it would be a common practice like when we test our headlight. The more simple I think it is. Like find our headlight now work, we go there and shake the wire and then we see it blink. So yes, alright, look like the bulb blow, so that I gonna make actually want to check the connector and the wires. So we just check to see if we have a broken wire or a poor connection. So once we do live data stream, the computer go in that mode, so it actually focus on that particular sensor. So once we wiggle the wire, any slight change in reading, it actually go trigger the code. So right there now, so for instance, it's not like we have a harness wire, so we have a lot of wire, sensor wire running in that harness. Once we wiggle test it, any value change from any one of the sensor them while you're doing that, it will just trigger the code. So right there and then now, it actually make you actually can fish. So you actually fish out that sensor in that particular way or method. So if we have a cam sensor, crank sensor, temp sensor, and other sensor running through a loom, any one of those have a poor electrical connect issue, the wiggle test I can actually make we bring it up, but chances are the part of the wire where we go, probably the part there now have an issue. So we have to go comb through the harness. So that can be a headache same way, depending on where the brake is. Right? So if wiggling a wire strips, so if wiggling a wire strips a code, you found the location of the problem. Right? Key on engine running diagnostic. Some vehicles support an engine running self-test. Test is performed with the engine running at full operating temperature. So check the condition of the sensor, actuator, computer, and wiring while they are operating under normal condition. Right? We have switch diagnostic tests. So some vehicles support a switch test that verifies switch input function. So you may be prompt to close different switches to verify their operation. Especially with these modern vehicles that have a module for like the lighting system and actually the wiper. So you can actually use the scan tool to operate the wiper blade. You can actually use it to trigger the pump. You can trigger the headlights. Anything that you can use what that involve a switching function, right? So you can use the scan tool to actually operate those. So there, right there and then now you will know if it is the switch itself or if it is a component. So for instance, we flip the switch for the headlights using the scan tool. You probably will hear the relay click, right? And once that relay click, when I see the headlight come on, chances are is either the headlight is faulty or the wire leading to it, right? So down here now we have testing progress cylinder ID, 6-cylinder, to test brake switch and power steering switch. Press and release brake pedal. Return steering wheel 180 degree and release, right? So the scan tool can actually tell you what to do based on your input. The tool will actually determine if the switch is actually working. So actuator diagnostic test. So uses the scan tool to order the vehicle's computer to energize specific output devices. Right? So in this case, actually using the computer to actually demand certain function of certain output devices. So it should have basically override what the computer is saying and actually telling it what to do. For example, like if we do a power balance test, meaning we want to find out which cylinder is misfiring, we can actually tell the computer, say, hey, turn off number one injector or coil. And then we can, if we not see a difference in power balance, where we can say, all right, cylinder number one is faulty. If we turn off cylinder number one and the car start misfire even worse, we know, say, all right, that is not the faulty cylinder. And we can just check across, turn off individual coil or injector, just to pinpoint which cylinder is actually down. So this test is actually very beneficial when it comes on to diagnostic test or troubleshooting, in other words. So allows you to verify actuator operation. Some of the actuator tests available: firing or preventing the firing of a coil, opening and closing fuel injectors, cycling the idle speed motor or solenoid, test drive. So all of these that we are going through is actually diagnostic methods. All right. So test drive. You can scan the vehicle data stream while driving to simulate the condition present when the troubleshoot occurred. and, and one easy way to simulate a condition is when you get a diagnostic trouble code. Most of those code, probably 90% of these codes are gonna come with something we call a data freeze frame data, sorry. So you will see like a frosted or a snowflake type of icon beside the code. So once I press on it, what it gonna do, it gonna tell you the condition under which the code actually occurred. So for instance, it can say the coolant temperature sensor was at 60 degree. Would have like partial shuttle or 75% shuttle. The coolant temperature was at this. The vehicle was traveling at this speed. The RPM was at this. So what you can do now, so for instance, you delete the code after you fix the problem, or you think the problem is fixed, and you scan back, you don't see the code come up. So when you go do a test drive now, based on what the freeze frame data say, so you can drive at that particular speed. You can use your live data to see when it reach up to the temperature where they say that when the code come up, right? So you actually duplicate the problem. So once you duplicate that condition and you don't see the code come back, you know, say, well, yeah, bingo, the problem fixed, right? So simulating the condition is actually good as well. So you can scan the vehicle data stream while driving to simulate the condition present when the trouble code occur. Some scan tools allow you to take a snapshot or movie to play back when you are satisfied, when you are safely stopped, right? So the scan tool can actually record the data stream. So if it's a case where you don't have like somebody else in the vehicle with you, so actually drive the vehicle while you are monitor what's happening. If it's you alone doing the job, you can actually record it. So the scan tool have that capability of recording. And then once you reach to a safe location or where you can safely stop, you can actually play back to see what occurred at this particular time. Probably you cannot drive and you feel a slight miss or whatever problem, but you're probably never able to catch it. So once you have it recorded, you can stop and replay that and say, oh, the value here did change, and I guess this is why we did have a misfire right at this particular moment. Right? So this is a test drive picture. So energizing OBD1 system without a scan tool. Yeah, give me a second. Sorry about that. I think some fire alarm just go off. So energizing OBD1 system without a scan tool. So there are several ways to activate the computer's onboard diagnostic and to retrieve trouble code. Always refer to the service manual for detailed instruction. Yes, so when you come on to like the OBD1 system them now, we have to be specific. Yes, so meaning the way you will be able to retrieve the code on one vehicle It not gonna be the same with another make, right? But it always required some bridging of pins. But you have to know which particular pins to bridge in order to retrieve your code. Like for under that, it's a bit more straightforward because just two pin. Once you bridge them, you count the flash. And the check engine light actually flash. So long flash is 10, short flash count as 1. I think with Toyota is E1, D1, but you have different pin for check different components within the Toyota one. So the Toyota one have more pins to deal with. All right, so so activating just a second. All right, the jump terminals AB and most GM connectors. Yes, so for this particular one is a GM connector. So they are saying once you put a jumper pin between A and B, you can actually get a code by doing that. So we have our designated jumper terminals. We have our jumper wire or paper clip, our diagnostic connector. All right. This one is for Ford. So jump the extra pigtail to a specific terminal, right? So self-test input pigtail jumper wire. We have our diagnostic connector down here, our tester lead. So you can see that the GM is a whole different process, right? So connect a test light across specific terminals in this connector. Watch the flashes or the trouble code. So for this one, instead of the check engine light flash, it actually requires you to use a test light, and then you would actually count the flash and that light to know what the code is. And that's between pin 4 and 2. Or just that this one them don't tell you which vehicle it is. And this other one him said turn the ignition key on, off, and then on, wait within 5 minutes, then on within on, then. All right, so turn the ignition switch on, off, and then on within 5 seconds. Will activate diagnostic on most Chrysler cars. So once you do that on off combination and then within 5 seconds again. So within 5 seconds after that, it will go in a diagnostic mode. Right? So with the Christ not require any jumper harness or jumper wire or bridging of pins. So this is why I was saying with the OBD1 system, it varies right across the board. So just imagine somebody driving a vehicle you never worked on before and them so they want it to be scanned. You know would have to, if you don't have the manual, you probably would have to tell the person so you can't scan it. If you don't have a scan tool and you try to retrieve the code manually. So with the OBD2 system, you see how it just make life easier for us as technicians. Alright, so this other one here seems like we're using the info infotainment system, or the radio, in other words, or the information screen, whatever. So them say trouble codes are other information displayed on that screen right here. And as I can see, when we look on the setup for this, I can see there's a OBD one below 2000 type of setup display right here. So over here now you can see where them say count lamp flashes, alright? And based on lamp flash, you can see right is the anti-lock brake system is at fault. So by pressing two buttons at the same time, the readout will display the trouble code, right? So this one is a different method of retrieving the code. So this one requires a button combination. So reading trouble codes without a scan tool, after activating diagnostics, codes may be read using various methods. Observing check engine light flashes, noting a voltmeters needle movement, observing a test light connector connected to the diagnostic connector, raising the climate control display, observing flashing LED on the computer. So some of those computers will come with like a little LED on them, sometimes green, red. So check engine light. So diagnostic code display. So check engine light flash one, pause, check engine light flash once again, and then check engine light flash. So as I always say, it flash once and pause. So you'd have like a second or two in between those pause for a long flash. And then it'll go flash and then flash. So two short flash, no pause between that would count as two. So if it flash 3 times without a pause, it's 3. One flash would be count as 1. So you gotta put the 1 and the 2 together. We're now gonna get 3 in this case, we're gonna get 12. Alright. So 1 would be like 10. So each long flash I gonna count as 10 in other words. So if we have 2 long pause, so flash, pause, flash, pause, and then flash, flash, would classify that as 22. Because we have 2 long pause flashes and then 2 short one. If we don't have no short one after the long pause, we know so that is a 10 or a 20 or anything like that. So during diagnostic, the lamp may flash to indicate the trouble codes, DTC, analog voltmeter, and Ford system. A meter is connected between battery positive and a specific terminal and the diagnostic connector. During diagnostic, the computer pulses the terminals to ground, causing the meter to sweep. Meter sweep can be read as a trouble code. So error code pulses. All right, so the digital readout bar graph shows trouble code. So diagnostic trouble codes 32 is shown. Right? So we basically each of these pulse is read as 10. So we would have 1, 2, 3, then we have a flat line which represents a pause, Then we have 1, 2. So we basically get a trouble code of 32 right there. So probably on our analog voltmeter would have like the needle would actually sweep and come back, sweep, and go back to a sweep, right? So we'd have that as 3, then it go pause when it come back, then it go make 2 fast sweep. So that's that is code 32. So back then life is kind of difficult with these OBD2, OBD1 systems, and how OBD2 actually make things more simpler for us. So LED display. So this computer has light emitting diode on the side of its casing. During diagnostics, the flashes can be red. All right. So trouble code chart. So P0171, when the air fuel ratio, and as we say, code 1 represent air and fuel. So the air fuel, all right, so in this column we have the trouble code detecting condition. So P0171, when the air fuel ratio feedback is stable. All right, this code set out right here. What type of system is this? OBD1 or OBD2?
2.
OBD2.
Okay. So that again?
OBD2.
Yeah. Because we know OBD1 code them normally have like 2 digits. Mostly. Well, the OBD2 codes normally are, as I would say, they are alphanumeric. So them normally start with a letter. And then 4 characters after the letter. Yeah, so as I always say, once you know the specific characters, we can tell which system it is. So when the air fuel ratio feedback is stable after engine warming up, the fuel stream is considerably in error or on the rich side. So what I'm basically I say is before the vehicle actually warms up, the computer of the vehicle in open loop, meaning the computer now taking a reading from the sensor, right? So it now calibrate the fuel stream. It just reach up the mixture for the cold start. But after the vehicle warm up, the computer will go back in a closed loop, meaning it will start receive information from the various sensors to adjust fuel mixture, right? So after I go back into closed loop, when it finds say still I get a rich mixture, the computer will actually try to make adjustment to that to a certain amount. And once it make adjustment to that particular amount and if you say no, change the make, it's going to trigger the code. Because the computer can compensate to a certain extent. Anything out of that, it will just deem it as fault. And over here we have our trouble areas. So we have our air intake, so hose loose, right? And that loose hose would have to be after the airflow sensor. Once the airflow sensor reads a certain gram of air passing, you would have to have unmetered air after the sensor. So with that, oh sorry, that should have actually lead to a lean code. So in this situation, it would have been before the sensor, sorry. So we have loose holes, and it can be clogged air filter, right? And it can be a faulty airflow sensor as well. So we have a free air intake, we have a fuel line pressure, the injector blockage, heated oxygen sensor malfunction, mass airflow meter, engine coolant temperature, and all the engine coolant temperature, rather that, it's actually a telecomputer, so the engine still cold, right? And probably the computer knows after a certain period the engine should be warm by then. So then those are the area where we'll actually go and check, right? And them say the P0171, when the air fuel ratio feedback is stable after engine warm up, the fuel trim is considerably in error on the lean side. Right, so in this situation now, where we have a fuel line pressure, just the same, injector leak, blockage, oxygen sensor, heated oxygen sensor. So we have a heated oxygen sensor malfunction, mass airflow, so almost the same symptoms at our core, engine coolant temperature sensor. And so service manual chart that shows different trouble codes, numbers, and possible problem and causes. And sometimes, like when we scan a vehicle and we retrieve a code, sometimes the scan tool itself will tell you the definition and the possible trouble area. But if the scan tool don't have those capabilities, we can just punch it into Google. And we get a list of possibility. So don't afraid to use up the search engines. Can use it to our advantage. Especially those codes that are them problem the way we know well problem finding. Once you have the code, you can actually go into some forums and we'll actually find others that having similar problems, and you can see how them actually solve their issue, and then you can actually come and try it and see if they will have any success. So as I said, don't afraid to use the search engines online. So erasing trouble codes, remove the stored code from the computer memory after system repaired have been made. Code should be erased after service to prevent misdiagnosis in the future. Yes, so sometimes we can like solve the problem, but we never clear the code. And then we actually think so we did clear the code. The vehicle come back, the check engine light on, not remembering that we never clear the code. And say, all right, the car, but it's the same problem. When really and truly the problem gone, but the code is just stored in memory. All right, so onboard OBD2 vehicle's code may need to be cleared to extinguish the main lamp. And with some vehicle too, once the code is there, the vehicle will continuously be in limp mode. So the vehicle will continue to be in limp mode until the code actually clear. Then stuff go back to normal operation. Especially with this hybrid vehicle, if you have actually a code with the battery pack or anything to do with the hybrid system. Once that code is on, once the check engine light on, or to indicate that we have a problem with that system, the vehicle probably not even will start until they actually rectify the problem and clear the code. So if they rectify the problem and not clear the code, the computer now gonna reset to go back in normal operation. All right. So there are various ways to erase trouble codes from the computer. Use a scan tool. This is the easiest way. Another way is to disconnect the battery ground cable. So unplug, and we can actually unplug fuse. So unplug the fuse to the ECM. Both methods erase radio, seat, clock, and ECM adaptive strategy memory. Right. So sometimes we like clean the chuckle body and like Toyotas, and then when we're done, the vehicle actually surge. So it idle up and down, up and down. So we can use a tool to actually erase those adaptive memories. Right? Or pull a fuse, whether it's the TPS fuse and the injector fuse for a particular time, probably like a 5 minutes or so. And wait for that code to actually lose memory. So code menu. So press one current code, and we have history code and clear code. Code erase. Are you sure? Press 1 for yes, 2 for no. So what this tool actually at the right here, so I can make sure say you not erase the code by mistake. So once you're sure say you want the code to be deleted, you delete it. So you can actually write down the code somewhere. Some scan tool actually can store it in history, scan history. So you can go back and have. So if you say, so if this car should come in back with a check engine light, you can actually make reference to the previous scan to see if it's the same history that come there or if it's a different code. So the tool actually want to make sure that you actually want to delete the code. And you're not deleting it by mistake. All right, so after clearing codes, re-energize onboard diagnostic to verify that no codes are present. This will help to verify your repair. DTC will be erased from memory automatically after 30 to 50 key cycle or warm-up cycle. So after 30 to 50 on and off, or just be regular starting of the car, or the same amount of warm-up cycle. That's where the computer actually, that are the period that the computer can use to monitor whatever issue was there to see if this problem is actually fixed. So once it's all right, I'm satisfied after those cycles, it will actually automatically, the code actually just go and the check engine lights out. All right. So I think that brings us to the end of this slide for today. As again, I'm sorry for the late start. Yes, I think the class will actually come to an end right here.
All right, good night.
Yeah, man, and thanks for the patience.
No.
All right.
Good night, Mr. Chote, you're still here. Mr. Chote? Yeah, man. Andre, Mr. Chote, you're still here?